Let's go through Liquid 1562. Find the last group of size M. It gives us an array ARR, which represent a permutation of numbers from 1 to n. And we are going a binary string of size n. Initially, all of its bits are set to 0. At each step I, and we change to the bit of this string to 1. So yeah, also giving m, so find the last step which exists a group of length m. A group of one is so group of ones is that continuous ones that cannot be extended to in either direction. So return the last step at which there exists a group once of length exactly m. If no such a group exists, return -1. So let's look at the example. We have an array. So we initially the first step, right? We put that in the third index, right? So once you find that this index is from 1, right? Third index from 0 to 1, and there is a group with size m. And the second step we put into 5, right? And so the groups, there are two groups, and there is groups with size m. And the third one we put in here. And the fourth step, we'll see this one is going to be one group. And we still have size one group, right? Step 4. But at step 5, if we put the number 4 here, right? So all of that, just one group left. And there is no size m group exists anymore. So we return step 4. So it is 4, right? Um, so for this question, we can thinking about intuitively we can think about is that we do reverse way, right? Reverse way to get a binary string which have all ones to get rid of an one, for example, 0 from this one, right? And trying to see what is the left 0 and what is the right 0, right? So if there is any left 0 and a right 0 to current index, there is a size m between it. Then doing it reversely, we get the last step, right? But the thing is that doing like this way, we need to put those kind of index, possibly in a tree set, right? Tree set or some to in tree set use a ceiling, floor or ceiling, right? But doing like this, it will be an O log n time complexity because that it will be an um, log operation in it, right? So we can do better. Do so. How can we do better for this question? We can thinking about another way is that we can do. We'll see. When we trying to insert one by one, right? Um, when we're trying to insert those one by one, and we have, for example, you insert one here, right? When we insert, we can insert trying to see whether its left is let's say we have create a B array, right? Which has we can have n plus 2, right? At a 0 because this index is from 1 to n, right? We can add a 0 at index 0 and at a 0 at index n plus 1, right? So when we insert, we check whether it's left is already at 1 or not, right? If it is, then we need to union this kind of index with these sets, right? And also we need to check on its right whether it is a one, right? If it is, we can union current one with its right, and we can get a size for the um new um union data sets, right? But the thing is that we want to find the last step which have the size m, right? So um we need to have a map to store those kind of um size and times, right? So for example, if we union on its right, on its left, right? Original this size, for example, it is A, right? Then the A's frequency will minus one, and A plus one frequency will add one, right? And when we uh union on its right, we also need to update the size and the frequency, right? So every time we do these kind of operations, we need to check whether the map have the size m or not. So this is a bit complicated, but we'll get our time complexity to be uh, O(n), right? Will be a linear operation. But this question actually we can do better. We don't need a union find at all. What we do is that we create an array called a length. And for this length, we have n plus 2. Okay. And for if the array is 1, right? And what we do is that we extend to all of its right ones, right? To be get a length here. And um so um also if it's on its left, there is a one, right? Or we extend all of its length to its left, right? And we put the new length to the left end and the right end, right? So we also have a count about the m counts, right? So if the m counts is greater than 0, then we have result plus 1, right? So doing like this way, um, we we can even don't need the union find. Actually, every time we add a number, we just update the it is like the union find concept, but that means that we just need to update this kind of because this one, right? For our new array, we create array. This already store what's the length here, so we can just jump to this index plus this length to its right end, right? And put a new length to that array. And also jump to its left and put a new length to its end, right? So the code will be much simpler. So let's write code for this concept. We have int n equals array.length. And we'll say if m equals n, we just return n, right? And we're going to have a length array. Let's set this one equals n plus 2, right? Because that the index here that is from 0, right? So for array, this is from 0 to n, right? So we also want to see its an index on its right and an index on its left, right? So the array is 1 to n, so there is a 0 added to this length to this one, and also n plus 1 added to the index, right? And we need int count equals 0, result equals -1, right? So what to do is that for int I equals 0, I smaller than n, I plus n, let's say this index equals array I, right? So we check this left, right? Left check this index -1. If it is 0, then this is 0, right? Once left there is nothing. And then right equals length index +1, right? So what we do is that we'll see the new length int new length equals L plus 1 plus right, right? So here the thing is that because we combined the left and the right, so we'll say if L equals M, right, we should have count should decrease by 1 because we combine to its left, and we get rid of one of the length M. And we'll say if right equals M, we'll have count decrease by 1, right? And then we'll say if new length equals M, we should have count should add 1, right? And then we set the new length to this array. But we add an index here, right? And we combine here, combine the left part and also the right part. So we put the new length at this element, and also this index, put here. So what we do is we just have length POS minus left equals new length, and the length P. This is not POS, it's index, right? Plus right equals new length. So we'll say if this count is still greater than 0, right? Then result we should equals I plus 1, right? Because this I step is from step 1, right? If you can also write I equals 1 to if small equal to n, right? But this array should index should -1, right? So in the end, just a return result. So actually, this concept is pretty much like the Union 5. But the thing is that we don't need to have maps to store how many um, the sets, right? Or also actually combine those sets. So we just use this length array to store the consecutive ones, the length at the left side and on the right side. So this is very fast. And also we can write a Python code for this. N equals the length array. So if m equals n, just a return n. Then we're going to have a length array. Array equals this one multiplied by n plus 2, right? Because this index is from 1 to n, right? And also we add one to the right, right? Because we will have one every index we need to check left, right. Otherwise, you need to uh, consider the corner case of the left and right, right? So we are going to have count in the result. Count equals 0 result -1, right? For I in range, and we're going to have index equals array I, right? So we'll have left equals left and right equals length I index minus 1, right? And this will be length index plus 1. So we'll see the new length equals left plus 1 plus right. And we'll see if left equals m, we'll have count the minus equal to 1. If right equals m, we'll have count minus equal to 1, right? And if new length equals m, we'll have count plus equal to 1, right? So now we store in the length array, this is not length, should be length array, right? We store the length array, the index minus left equals new length, right? And also the length array index plus right equals new length, right? So let's say if this count is greater than 0, we can still have results to be I plus 1, right? So in the end, just return result.